This video is looking at coordinate geometry of the line. In particular, it's looking at coordinate geometry of the line worksheet number 4, and this video is focusing on the slope of a line, and in particular finding the slope of the line by reading slope values from a graph. We've already seen how to get the slope using the slope of the line formula, and way 2 here you can see is written in blue. It says picking slope values from the equation of the line. That's another way of working out the slope of a line. However, we're going to come back to this after we have completed the equation of the line. This video then looks at the third way, which is we can get a slope of a line by reading slope values from a graph. So if you have your x and y axis drawn, you have your line, we're able to get the slope by reading certain values from that graph. So the slope of a line can be given by the vertical change divided by the horizontal change, and in maths we call this the rise divided by the run. So that's a key thing, and the formula we have is the slope, which we know is m, is the rise over the run. So remembering now that the slope can also be negative, so the rise can be negative as well. So if we're looking at the line that I have drawn there in the coordinate plane, we read again from left to right. So when we're reading this graph, you can see that the rise is definitely positive. So when we're reading to left to right, it's going uphill, so there's a positive slope. However, if I draw another graph like this, when we are reading from left to right on this one, it's definitely a downhill slope, so it's negative value, so the slope is going to be negative. So to find the slope value from a graph, I have kind of a few steps how we do it. So the first thing we do is we draw in two lines to form a triangle like the one below anywhere on the line. Now we're going to go through an example of this, so it will make much more sense when we go through the example. The second thing you do is you count the horizontal change, which is the run. And the run is always going to be positive because we always read from left to right. Then we count the vertical change, which is the rise, which may be positive or negative, so it may go up or it may go down. Then the final thing you do to get the slope is you just put the rise over the run. And then if you want, you can type that into your calculator, because sometimes you might get a fraction that is, for example, something like 6 over 12, which of course you should know breaks down into 1 over 2, but we might not know that. So to double check, always just type the slope into the calculator, press the equals to sign, and it will break down the fraction for you if it can be broken down. Now, so a few examples, just to kind of get an idea of how to complete them. So it says calculate the slope of each of the following line segments using the grid provided. So we have the first example here, and I'm going to start by writing down the formula. So m, which we know is the slope, is equal to the rise over the run. So we pick any 2 points in the line, and they've given us 2 points here. So this point here, and they've also given us this point here. You can pick any 2 points though, it doesn't matter at all. Any point along the line will give you the same slope. So then we draw a triangle. So I'm going to draw a line out here, and then a line down here. And you can see that we have a triangle formed here. So the rise needs to be how high this triangle is, so from this point to this point. And if you look there, you can count the units, so it's 1, 2, 3, 4. So it's up 4 units, so the rise is 4, and it's positive 4 because it's going up. And then we have the run, which goes across 1, 2, which is equal to 2. So then the slope is the rise over the run, and 4 divided by 2 is going to give you 2. Part B then, next. So again, I'm going to write down the formula. So the slope is equal to the rise over the run. So if we draw that in, so I'm going to choose the points that they've given us again. Draw down the triangle. And draw across the triangle. Now, so again, we have to see the rise here. So that's from here up to the point that we have. So that's 1, 2, 3, 4, 5. So then you need to ask yourself, if you're going from the left to the right, is it going up or is it going down? And the rise here is definitely going down, so it's going to be -5. Then we need to get the run. Now, so the run is from this point here to the point on the line, and if we count that, that's 1, 2, 3, 4. So the run is 4. So the slope of this line is the rise, which is -5 over 4. So -4 over 5 is the slope of this line. Example C is next. So again, the first thing we do is just write down what the formula is. So m is equal to the rise over the run. So we again have been given 2 points, this point here and this point here. So I'm going to draw the 2 lines that form the triangle. Like that. Then what we have to do is we have to calculate the rise first, and the rise is from this point here up to the point we have at the top. So we can count that. It's going to be 1, 2, 3, 4, 5, 6, 7. Then you ask yourself, is it from left to right, is it positive or is it negative? And in this one it's definitely positive, so the rise is +7. And then the run is from the point on the line out to the point where the 2 lines meet. So that's 1, 2, 3, 4, 5. So the run then is 5, and we can fill in the formula. So the slope is equal to the rise, which is 7, over the run, which is 5. And example D is the next one. So we always start by writing out what the slope is. The slope is the rise over the run. So the next thing we have to do is pick 2 points on the line. They've given us 2 points here, this point here, and this point here. What we should be able to do next is just join those 2 points together. To form the triangle. We need to look at the rise first. So the rise is from the point where the 2 lines meet up to the point here. And that's going to be 1, 2, 3, 4, 5, 6, 7. Then we ask ourselves, are we looking at a graph that has a positive slope or a negative slope? So when we read from left to right, is it going uphill or downhill? This slope is definitely going downhill, so it's going to be a negative. So it's going to be -7. And then the run, we get it from the point where the 2 lines meet and the point at on the line. So that's going to be 1, 2, 3, 4. So the run here is 4, and the slope then for this line is going to be -7 over 4. So looking over some of the types of questions that you'll be asked in this worksheet. So the first question we have in questions 4.4 asks you to calculate the slope of the line using the grid provided. That's going to be literally like the examples that are in the last slide. So picking up 2 points on the line, and then calculating the rise, calculating the run, and putting the rise over the run to get what the slope is. Question 2 again is very similar. The only thing here is they ask you to do it in steps. So the first thing they do is, using the coordinates given, calculate A, the rise, and B, the run of the line segments AB. And then it says use these values to find the slope of the line segment. We're fully aware that the slope is equal to the rise over the run. Making sure that every single time you talk about is the line uphill, and if the line is uphill, there's a positive number on the rise, and if the line is downhill, there's a negative number on the rise. The third question then asks, why is the slope of the given line negative? So all we have to realize there is, well, it's going downhill, and if a slope is going downhill, it's definitely negative. And then it says use the grid to work out the slope. If you can do question 1 and 2, you can definitely do question 3. Question 4 then says 3 line segments A, B, and C are drawn on the grids below. Which segment has a slope of 3 over 2? What is the slope of line segment A? What is the slope of line segment C? So what I would do for that one is I would work out the slope of each line, and then you should be able to see which one has the slope of 3 over 2, and then you'll be able to figure out the slope of A and C too. Question 5, the first thing it says, which of the lines A, B, C, D or E, F has a negative slope? So that's the one that's going downhill when we're reading from left to right. I'm hoping that that's okay. The second part then says, write down the coordinates of the point A, B, C, D, E and F. That should be hopefully fine. Using the formula below, find the slopes of the line segments A, B, C, D and E, F. I'm hoping that if you can do question 1, 2 and 3, you should be perfectly fine with question 5. It's very, very similar. Question 6 then says that a ski jump consists of 2 parts, the descent and the lift, and in the diagram find the slope of the descent and the slope of the lift. So that's exactly like the last few questions, it's just giving it a real life application. So that is the end of this video for the third way of finding a slope, which is reading slope values from a graph.